my name is Rich Howard, owner of Architectural Builders Supply, and this video is to attempt to replicate a door pull that a client sent to us. I saw the photos and I immediately realized, well, this is going to be 1960s, would be my best guess in terms of a vintage. Okay, we'll get the software pulled up here, and the end mill I'm going to use will be an Onsrud 2-flute up spiral carbide, 1/4 inch diameter. I'd like to use 1/8 inch. I just finished a job with a lot of 1/8 inch cutting on it. I had a random piece on the table and I was just filling tiny little nuisance orders, and the 1/8 inch was great, silent, very little materials obviously being cut. They're very fragile though. You have to be mindful. They're so easy to snap you won't realize that you did it. But I can't get the length of cut needed. I've got to go to 1/4 inch diameter. The point is I was cutting all these pieces out for a job I was doing, and I wanted to test an 1/8 of an inch, and it worked out really great. There may be a 3/16 like I was trying to say with the length of cut I need, but it's going to be 1/4 inch. So this is the job that we were in, that I was working on. So what I'm going to do is actually pause this video, and I'm going to position the piece on the work table where I want it to be, and make a couple of other decisions. So let's move to that real quick and we'll come back. Okay, let's walk over and take a look at the piece of aluminum we're going to be using. 1 inch thick. I'm actually going to put the caliper on this a couple of times and see if I feel the need to surface this at all. Obviously I'm not going to be able to determine exactly how uniform it is, and I don't want to surface it unless it seems to be wildly out, because, you know, I need to be able to get through the piece. I've got a really deep, very narrow channel that I'm mortising. I really wish there was a smaller diameter end mill for this job, because I'm removing more material that I'm using for this, is the unfortunate reality. So I'll put the camera down and I'll grab that piece and we'll take a look and see what it is gonna potentially look like. You know, the other thing with getting it positioned on the table is I want to be able to minimize how much of the work goes on the floor. I want it to all go up into the dust collector as is the role of a dust collector. The zones on my table are 2 foot by 4 foot, 2 foot by 4 foot, 4 foot on the X. So maybe what I'll do is just stick in one zone. Anyway, let's grab that piece. I don't recall the weight of what this was, but I guess it was somewhere in the 60-pound range is what this piece of aluminum actually weighs. You know, fixturing it down is going to be something that we're going to have to think about. And vacuum, it's so heavy itself initially, at least. You know, obviously it would be really nice if I had a 4 foot by 4 foot sheet, because I would be able to clamp the 4 outside corners. I'm only going to get 3 corners on this smaller piece. But our feed rate is so slow, our pass depth is so shallow, that I'm not concerned really at all with how much energy we're putting into this. So let me grab the caliper and let me take a couple of measurements. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now let's get back to it. I'm getting 1.04 on this outside area here. 1.38, 1.39, pardon me, 1.039. I can only imagine what this full sheet weighed. A little bit smaller over here, 1.33. That's obviously very tiny, but I don't like inconsistencies like that, obviously. 1.35. Yeah, so we're going to have to count on its thinnest. The problem is we've got a thickness that's uniform, but I'm not sure the term, but if we were to put a laser level, we would find that this thing is not level. I can see it's not level. I'm going to flip this over. It appears to be cupped at this point slightly. And the point of the idea of surfacing it is I don't want this thing to rock on the workpiece at all. Yeah, it's bowed. No amount of vacuum's gonna pull that straight. No magic that we here can conjure. So the issue becomes is its thickness is not what I'm measuring. It's actually the maximum distance from the crowned top of the material to my machine bed. That's really the thickness that we're dealing with. And that is a bummer. When I go for my machine bed, yeah, it's way thicker. When I go to the machine bed down to the top of the material to the machine bed, .75. It's really huge. That's 40 thousandths. Yeah, it's quite unfortunate that that's the case. No, vacuum's not going to work. We're not going to run the vacuum on this. We're going to clamp it, and maybe someday I'll consider driving the fork truck and parking it on top of here overnight. Ain't going to work. It wouldn't work anyway. The issue is if I'm going on 1.35, I'm not going to get through the material. So I've got to think about it being thicker. The tabs are going to end up being thinner in those thinner areas. This piece of aluminum cost $500 just to put in, and I'm not suggesting that that's expensive, but I suppose just recording it. Yeah, this piece that we just flipped, 1.67. So there's for sure a 30 thousandths deviation in what's happening here. If I use a thinner material thickness, two problems. I'm not going to get through the material when it's thicker, and when my end mill starts, it's going to start prematurely cutting into the material. So where I zero off of is obviously going to be at its highest point because I don't want to really chew up my end mill. And when I'm cutting into the areas that are flattened more, I'll make several passes and not even be making contact with it yet. We've got to count on the thicker material. I want to take a look at the other side of this. Come up with possibly some sort of a median. 1.65. Pardon me, 1.065. 1.067. That's probably what I'm going to run with. 1.067. Or we can surface it. You know what? I'm thinking I'm going to try that. I'm going to try a surfacing routine on this because there is a bit that I've been wanting to try. Yeah, we're going to surface this. I want it to be uniform. I've been cutting so many jobs of aluminum where it's just been a matter of why is my depth so odd in different parts of the work? And it's because the material is not consistent in terms of its stance, its relative position off of the machine bed. The material is not consistently flat, and that's really the problem. So let's walk over and let's grab a couple of end mills. And the one that I want to show you actually is not even in the Onsrud catalog, but I think I had cut something with it, and it was ridiculously like butter. Yeah, we'll grab this end mill. I think this is a 7-flute Onsrud end mill that is probably for some I believe it's for an exotic material. Now the end mill that we're going to run with on this job, it's this AMC 701-402. I've got two of these, and that is the 1/4 inch, 1.25 inch length of cut, 2-flute, up spiral, carbide. I've got some AMC 701-403s coming. It's the same thing with just a coating on it. You know, my logic with the coating, originally it was, why buy the coating? I'm snapping the end mill anyway. So, however, I haven't broken an end mill in several days, knock on wood. So at some point, we're really going to have to get an understanding of what we're dealing with. So let's take a look at this exotic 7-flute end mill that I've got here. And this might be a complete bust. I'm not sure what's going on with this. I may have bought this on eBay. I don't know. And as a result, it's going to be really trial and error on what I'm doing with this. But I'm thinking I'm gonna try to surface with this and see what happens. I'm going to, is the bottom line. And if it doesn't work, we'll use a bit that's more tried and true for what we're doing. AMC 701402, this is in the high performance catalog from Onsrud. We are an Onsrud distributor, and obviously that's why I'm using Onsrud, but it's also because I really do believe in the product line. I've been using some SGS lately because I've been able to buy that from a supplier, and I'm not dissatisfied with the SGS at all, but my initial reaction is that the Onsrud seems to be sharper later in the process, and this is deadly sharp right now. And my opinion on Onsrud, after I've cut untold lengths, runs of material, that it just stays deadly sharp. So this is the tool I'm going to run on this. I do have an SGS end mill that I was considering using, but because Onsrud's going to be my daily driver, I just want to run with that. So we'll switch to the screen view, and we'll take a look at a surfacing routine on this after I determine how I'm going to position this. Well, not much to determine. I've got to be able to anchor it at 3 points. And we'll think about surfacing it because I would really like to be uniformly coming through a thickness, leaving a consistent tab height, not going so deep into the machine bed because I'm calculating on a greater thickness, etc. You get the routine. So let's switch to the screen view. All I'm going to do is just figure out how to position this. I'm going to kick it over here a little bit, kick it over here a little bit, clamp it down, and fingers crossed. Let's move on. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.